And here's a 100% electric airplane. This is your airplane right here. It's flying. This is the future of aviation. Hi.
Hello, Nicolas.
So please introduce yourself. And H55 is your company, right? Doing this electric airplane.
Sure, that's right. Yes, my name is André Borschberg. I was a co-founder and the pilot of the Solar Impulse project. You may remember the airplane which flew around the world, the electric airplane which flew around the world powered only by solar energy. And 3 years ago, with two of my former colleagues, we decided to spin off the technology that we developed at Solar Impulse for 15 years to bring it to H55 with the goal to develop electric propulsion system for aviation. So really to take the path to make aviation clean and quieter for the future.
And right now, the aviation industry, I mean, it's a huge $1 trillion industry and it's having some real issues right now with this corona, right? So everybody's kind of thinking the big thing now, it needs to be clean aviation, right? And you're the forefront of this. You're making it happen.
I would say very short term, the big things is for them to survive. I guess the big aircraft manufacturers and even the small one, it's not so much an issue. It's more the operators, the airlines, the airliners who have to find a way, in fact, to go through a difficult moment. But it's clear that people will travel again. I hope they will not travel too much because that's not what we want to have people all around the world. But it's certainly also a very strong impulse for the aviation industry to move it from a fossil-based technology towards clean technologies. And with existing technologies, it's possible to do already many steps. Of course, you cannot have a 747 or an Airbus 380 fly electric tomorrow with the existing solutions, but we can certainly start today, and that's what we are doing with smaller aircraft to build up experience, to build up, collect data in order, in fact, to be able to develop larger systems, which will come in a few years.
So you are having like 1 hour of battery plus a half an hour. Is that what you are currently able to do with your airplane system?
For our first application is to electrify flight trainers, and these airplanes normally have a typical flight mission which lasts an hour. That's the time it takes for strict takeoff and landing, and after 1 hour they are completely exhausted to go back to the airport. And with an airplane which has about an hour and a half endurance with the existing battery technology, it's absolutely perfect. So that's what the flight schools are looking for with the existing technologies. Now there are different battery technologies which are coming, which will offer a much better energy density. So I think slowly we'll be able to move up this line of endurance, going to 2.5 hours. So after a year, it's going to be better. And it's interesting, when you buy such an aircraft, such an electric aircraft, you buy it with existing technology, but basically you have a contract with us. And after a couple of years, you will have to change the battery cells. It's part of the offer we make to the clients. And each time, in fact, you buy a new battery set. In fact, the battery set will be of better quality. So instead of having an airplane which gets older and older in terms of technologies, you have an airplane which gets younger and better in terms of power supply, energy, technology, and so
on. One thing that would be nice is if you could design it with having a battery swap, because I'm a little bit enthusiastic about battery swap potential in electric cars. And I think it would be great if people could just land, swap the battery, and fly again. Is that possible?
I don't think it's possible because it's, in airplanes, the level of safety is extremely high. So if you have someone manipulating batteries, even having to switch, and put a switch and connect the batteries again and again, the risk you have a malfunction happening is pretty large. So I think it will be difficult because of this high level of safety that you have to achieve in aviation. But the speed and the time to recharge the batteries is also very interesting. Currently, we have an hour. We planned to go down to half an hour over the next 12 to 18 months. It's just a question, in fact, of managing the temperature in the battery pack. So if you can recharge in half an hour, it's more than enough. That's the time it takes to debrief with the students, brief the next one, and go back into the airplane. So I don't see this as an important issue from what we are told by the flight schools.
So I've been watching some of your videos, and I think you're being careful about people hoping that all of commercial aviation is going to go, for example, electric. That's what I'm hoping can happen faster than some people might imagine, right? But let's say you have a regular oil-powered airplane going 10 hours. If you can go 1 hour on a battery, that might actually cover a lot of like EasyJet and Ryanair routes, So isn't it just a question of having a powerful enough engine?
It is, but I guess running on batteries with existing technology would not be enough, because in fact these aircraft are highly loaded, and because of these big loads that they carry, passengers, luggages, and so on, you need also a high power aircraft, and you need a strong source of energy. So I think the way the industry is going short term is on a hybrid technology. So still initially using fossil energy to generate electricity, but this would already allow this aircraft to take off and land on batteries, so make them much quieter when they are very close to airports and houses and cities. So having I would say the first part of the flight quiet and clean, and using the hybrid technology in flight during cruise to make sure you get the endurance. The next level will be potentially to use hydrogen instead of fossil energy. In this case, you could make it really clean. Hydrogen, when combined with oxygen, is just generating water, so there is no CO2 effect which comes out of the fuel cell. So this would be a technology which could equip commuters airplane, initially smaller ones. We could start by having electric air from Paris to London, taking off and landing on small airfields closer to the city, as they don't make as much noise as in the past, compared to existing solutions. That would certainly be a way to go. So I think the transport industry will change a little bit in the way it will use these technologies, with the advantages that they will provide, certainly by being clean and, as I said, quieter.
So I can imagine that some of the technology that has been transferred from Solar Impulse has maybe to do with the engine, the electric engine. Is it? Can you describe a little bit how powerful it is, and what goes into having an engine that can lift up somebody on batteries?
Solar Impulse was very special because it was the first airplane able to fly with an unlimited endurance. The longest flight I did was 5 days, 5 nights, non-stop. I could have flown longer. In fact, the airplane could fly a month as it gets its energy every day from the sun and provide it as electricity, in fact, to the batteries and the motors. So it was very light, extremely efficient airplane, and small motors were sufficient, in fact, to propel it forward. Now with these flight trainers that we the technology we built for flight trainers for the intended to equip the flight schools. Of course, up power. We are at about 100 kilowatts. The next step will be 4 to 6 seater. So we'll go direction 300 kilowatts. That's about 500 horsepower. So slowly, in fact, we'll go up in terms of size and power of the technology. But I think the motors is not so much the difficult part of it. I think the difficult part of providing this technology to the world of aviation is to demonstrate that they are completely safe. That's what you call certification. You may have followed what happened to the Boeing 737. They had two airplanes which have crashed. All the 737 have been grounded for a year and a half. I think they restart flying them now, but it took Boeing 1 year and a half to just recertify the small software that they had, which did not work well. And so this certification process is tedious because you have to make sure and you have to demonstrate to the authorities that no failures, nothing which could happen in whatever electronic board, whatever could happen would lead to a catastrophic situation. This takes time, this takes money, and that's exactly what we do at H55. That's the reasons that we are 30 and soon 50 engineers, just to demonstrate that our technology is safe. That's reasons why we raised another 20 million last months in order to accomplish this task and fulfill these requirements.
I'm hoping that the EU, Switzerland, all the governments are taking this as a big priority and really want to see this happen faster and sooner, right? Because we are eager to see not just electric cars everywhere, but electric airplanes, like the technology advance, and it should be a huge priority, right? You're getting support from the Swiss canton and governments?
Thank you for asking. Yes, we do. We had support from the FOCA, that's the Federal Office for Civil Aviation. That's the FA in Switzerland. And they redistribute part of the CO2 tax that we have in Switzerland to finance the development of this new technology. So that was one of the support. And the second support we get is from the local canton. We are based in the canton of Valais, which is well known by the skiers, because that's in this canton that you have places like Verbier, like Zermatt. And this canton is developing and putting a lot of emphasis to develop and attract new startups, new technologies. And the reasons why we were supported and it's subsidized, partly at least, by this canton, is that our technology is also closely linked to the technology which is developed by the local universities, the École Polytechnique Fédérale de Lausanne, which is also for all the questions related to energy, clean energy. It's also based in Sion. So yes, that's very important. It's very important because companies like us do not get profitable immediately. You need quite a lot of investment. So you need investors who believe in the long-term benefit of this technology. You need local support from governments to make sure that, in fact, companies like H55 can go through this development process. I think we are fortunate that we worked 15 years at Solar Impulse. We gathered a lot of experience, a lot of data. Both airplanes have been using lithium-based batteries technology. We had to certify this airplane in order to be able to fly over cities like Shanghai, like New York, something which is a little bit crazy with an experimental airplane. So we had to demonstrate that our airplanes were safe to be able to have the clearance to do so. So of course we have taken all this experience we made and brought it to H55. I believe in a step-by-step development. So I really believe to start from simple and go to big challenges, And I think the road through the small aviation is extremely attractive, but of course, it should not stop there. I'd like to see commuters airplane. I'm sure I will see commuters airplane flying electric. We'll very soon see VTOL flying taxi. That's another world which is in development today. So something which can take off like a drone. You see this small electric drone, but then fly like an airplane with wings, carrying passengers from one side of the city to the next, using electric propulsion, so being clean and quiet. So that's certainly another way, in fact, to move around big cities, which is coming and which will be coming very soon.
So the Solar Impulse was over many years. I did a video 10 years ago, actually, with your colleague Bertrand Piccard. And can you consider this a little bit like the Swiss Apollo project? This was like it's like amazing kind of collaboration, not just only Swiss, right? You had people collaborate and companies collaborate from different countries, right? And now it's in Spain, as far as I understand.
Well, it was a private project, and you can see that around the world, it's not so much the public institutions which now trying to be at the forefront of the technology. You can see that Elon Musk has developed new type of rockets, which can bring people to the International Space Station, maybe with a goal to go further to the moon later, or to Mars. But these are projects which are enormous in terms of financing required. And interestingly, the government today are so indebted that they have big difficulty to finance this vision. So it's coming from the private industry. Solar Impulse was financed by partners, industrial partners, for most of them who believed that they didn't only believe in the technology, but they believed also in the importance to show the world what we can do with these technologies. And of course, if we can do this in the world of aviation, which is extremely difficult, you don't cheat in an airplane. If it doesn't fly, it's clear. And if it doesn't fly well, you cannot fly day and night. So if we could do this in airplane, we can certainly use this technology on the grounds. So yes, private companies, private funding are extremely important to bring the world now into a new direction.
How was the feeling flying the Solar Impulse plane? And when you were flying, for example, the 5 days, was it quiet in there, or was it noisy, or?
Feeling, you look up in the sky, and you see the sun, you see these sun rays, and just this energy is sufficient to propel the airplane, to make it climb to 9,000 meters, to recharge the batteries enough so that you can fly through the night. So it's an amazing feeling, and to have the potential to fly indefinite, so days after days, without the need to stop, without being dependent on bringing energy from the ground. This was fantastic. But it's also, when you board an electric airplane, it's also interesting to see. It's a bit like cars in some ways. I mean, you have absolutely no noise. You have nothing to do to preheat the airplane, so you just have a switch, and when the switch is on, but the lights on the aircraft are on, the system is ready to work. So as soon as you push the power level, the prop turns. It's quiet. I mean, you see it turning, but you don't hear any noise. And you take off. It's like a sailplane which is able to climb. So no vibration, no negative feedbacks from the technology. So it's truly overwhelming.
And you're doing a huge distance. I mean, you're going all the way from Hawaii to San Francisco. Or you went from Japan to Hawaii.
Yes, exactly. I did the long part, which was from initially from China, but we decided to stop in Japan because the meteo was getting worse over the Pacific Ocean. And we knew that we had to take 5 days, 5 nights to cross the ocean. We also knew that we had to go over a front. There is always a front, is something like a wall made of big clouds, which do not allow you, in fact, to go over. So we had to wait until this front or this big wall would diminish in intensity, and to give me the chance to climb over at 9,000 meters and just go on the other side. So this was the big challenge, and I could do it after three or 4 days. And the difficulty we had was to find, in fact, this right weather window. So we have been waiting 2 months in total, 1 month in China, 1 month in Japan. And, losing phase, the team was getting extremely tired, losing the starting to be a bit negative. And it was a difficult moment to make and to keep everybody motivated. But fortunately, by the end of June, we did find this weather window. Unfortunately, I had a technical problem, so immediately the engineers asked me to go back. We refused, Bertrand and me, and I decided to continue. And I thought, I can manage this technical problem. It's more important to use this improving weather window to be able to cross over to Hawaii, which I finally did. But the level of emotion at the moment of deciding to continue against, in fact, the recommendation and the will, basically, of engineers was a very, very strong moment.
What was the technical problem that you had, and how scary was that?
We had, as I was planning to fly 5 days, 5 nights, I needed to rest. And when resting, I needed to have a system which would tell me if the airplane would suddenly go out of controls, because we had some kind of a stabilization system on board. It's a little bit like an autopilot, but it's stable only when there is no turbulence. As soon as you have turbulence, the system is unable to cope with the airplane moving, and you have to take the airplane manually. So we needed to have an alarm system which would wake up, bring the attention of the pilots when this stabilization system would not be able to manage the situation. And I call it the virtual co-pilot. This virtual co-pilot failed after takeoff, which made, of course, difficult afterwards the possibility to rest. And I had other systems available, but which were not fully tested. I knew them because I was part of the team which really not worked on it, but really looked at it carefully. So I was confident I could find a solution, but it was not part of the available material. That's reasons why the engineers thought that without this system it would be impossible to do it. And I thought that with the experience I had with the rest of the airplane, I could manage this failing system, and that's the reasons why I decided to continue. And effectively, I was lucky enough to be able to manage. I think but it ended up by splitting the teams really in 2 parts at the end of the flight, and it took us a few months, like you have couples which had the difficulty and lost trust. So we had to use some external therapy to bring back the position of everyone and to rebuild, the team that we had at the beginning of the flight around the world. So sometimes, when you do something new, you have to you have to change the way you go about things, and that's what we had to do there at this moment.
And this system is being like, the potential is that it could be like a satellite that can just be constantly flying around. That's one of the things they're doing in Spain with it, right?
That's exactly this. Yes, we worked on this idea of using this technology to build the same but unmanned, which could fly a month, for example, at certain location, doing observation, measurements, communication work, came to the conclusion that the project was huge. And one of our partners at the time decided, in fact, to launch a project in this direction. And this project exists today under the name of Sky Dweller. And Sky Dweller is using our technology to build these unmanned platforms, which could partly replace satellites, something which can fly clean because it's using solar technology, which is brought back down when the application is completed, and doing potentially a lot of things. As I said, communication, observation, surveillance of sea, forest, boundaries. I mean, there are a lot of things today where surveillance is extremely important, and this info will be very valuable.
So I guess one of the big dreams in aviation is to have an airplane where you kind of feel like a bird, right? Where you don't have the big engine doing a huge noise. Is it a little bit the experience in the H55 where you're just flying around and nearly quiet? How quiet is this propeller?
But you know, the experience is incredible. Think about having a hangar on which you have some solar cells, maybe a battery in between. You plug your airplane on these solar cells. You fill up your own batteries in the airplane. You take it out and you go in the air and you fly. So first of all, you fly cheap. Extremely cheap, because of course you have to finance the investments, but when the investment is financed and the biggest part of the cost to operate an airplane comes from the fuel. You know, when you have an hour of flight with a transport airplane, I guess 25-30% are the fuel cost, so it's huge. So if you can bring this to zero, it makes an incredible difference. But then, as I mentioned afterwards, you know, you have something which is which makes absolutely no noise, which brings you up, which makes no vibration. So you say it's like a bird. It's a little bit more maybe than a bird because you still have an infrastructure, but it's freedom.
And how's the speed? Because I can imagine maybe it's not the normal kind of speed that you would have on this car, on this airplane, if it was using a conventional engine.
I think it depends on the application again, and how long. You know, if you look at Tesla, I don't know if you drove a Tesla, but the Tesla is incredibly powerful. I mean, the Tesla is better than a Ferrari in terms of acceleration, with the technology which is extremely simple, which is also much cheaper. So electric motors are extremely powerful. They have a high torque, which is used, in fact, for electric cars, and in fact for this acceleration, but it's also very useful for, of course, for airplane. So then it's an optimum. In aircraft, of course, it's the same with fossil energy. It's always a compromise between the power that you need, the endurance you want, and the payload you want to carry. And the better you are in terms of efficiency, the more interesting it becomes. Electric motors excellent compared to combustion engine. Efficiency of electric motors is 95-96%.
So everybody can check the H55 YouTube channel, which is showing all this amazing footage. As Facebook also, you can follow on Instagram at H55, showing all the progress reports. Your technology is going to be certified and available on the market, like with different manufacturers, right? They're going to just integrate it and sell this in the next couple of years.
That's right. And will be used by aircraft manufacturers initially to small airplanes. So I hope that by 2022, you will not be able to hear this airplane flying over your heads.
That's going to be fantastic. And I'm hoping that the next step is even, like maybe, let's say the governments and stuff, they say, let's make it a bigger priority. And if they suddenly say, we want this to go faster and in bigger airplanes, there might be ways to start engineering that, right? Or to think in that direction, even faster.
That's in the roadmap as well. Of course, we could accelerate, but that's part of what we want to do. I think it's good to build up on the experience we make, collect a lot of experience, so really go step by step. But of course, if we can go faster, would be much greater.
All right. So thank you very much for connecting. Sometimes the internet or something might be a little bit unstable. Thank you very much for explaining your what's happening in over there in Switzerland, but changing the world. All right. Thanks a lot.
Great pleasure talking to you, Nicolas. Bye-bye.
Thanks. Thank you.